Good morning. We are going to do, so I know we did 10.6 last week, but we're going to do 12.1, which is really the second section in this chapter. So again, I typed up the definitions. There's only two. That way you can screenshot it, do whatever you want to do. You don't have to copy it down if you don't want to. But basically what we're going to talk about are tangent lines. And what that means, a tangent is any line that touches a circle in exactly one point. Okay, so if I tell you a line is tangent, it touches a circle in exactly one and only one point, and no other times does it touch that circle. And then the point of tangency is obviously the point of which the tangent line and the circle intersect. Okay, so in our first theorem here, we have if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So, in this picture here, AB, the line in red, is our tangent line, and it touches the circle exactly one time at point P. What this theorem is saying, and remember, you can draw infinitely many radii in a circle. So there's always you can always draw a radius from the center to the point of tangency, okay? Like there's a bajillion radii in the circle. Okay, we're just talking specifically about the one and only one that travels from point O to point P. And all this theorem says is that when you draw that radius, OP is perpendicular to AB. So the radius is always perpendicular to the tangent line. Okay? So with that knowledge here, we have our first example. They're asking me to find the value of x. And if you look at this, immediately you're probably thinking a couple things. One, I have no idea. B, you have two angles that are unknown and only one that you actually know the value of, but that's not all entirely true. So, as we just recalled, they tell me in the directions that both of these lines, ML and MN, are tangent. Well, this is a radius, and that is a radius, and they are intersecting the lines that appear to be tangent at the point of tangency. Okay, well, from that information alone, I now know that that angle has to be 90 degrees, and that angle has to be 90 degrees from the theorem that we just discussed. Well, the next part that's probably making this problematic is you're probably wondering, well, how many, it's not a triangle, so 180 degrees is not the sum of an interior figure. This shape has 1, 2, 3, 4 sides. Any figure with 4 sides has the interior angle sum of 360. Think back to your chapter 6 stuff. All right? Well, all I need to do is take my 90 plus my 117 plus my 90 plus x and set that equal to 360. All right? When I add up all the ones that I know, that gives me 297 plus x equals 360. And when I minus my 297 from both sides, not 95, 297, x equals 63 degrees. Okay, so again, the angle N and angle L are 90 degrees because they are, those are radii to a line that is tangent, therefore they are perpendicular or make right angles. So I know those two angles are 90. I was given angle O at 117. The shape OLMN is a quadrilateral. It has 4 sides. So there's 360 degrees inside of all 4-sided figures. And I added up the 3 angles that I knew and subtracted that away to find the 4th angle that I was looking for. Now, the next example you are to do on your own. So pause the video, take a shot at it, and then check your work. Okay, so similar set of directions here, very similar problem. They're saying ED is tangent to circle O. What is the value of x? The only difference here is that this shape that they've given me is a triangle. So your magic number here is 180. We know that OD is a radius to a tangent line, so that's 90 degrees. All right, so if we take our 90 plus 38 plus x equals 180, and if we add up our 90 plus 38, we get 128 plus x equals 180. And 180 minus 128 is 52 degrees. Okay? Your next theorem tells me that if a line in a plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent. So this is just the converse of what we just said. So what I'm telling you now is, here's a radius, here's a line, and when the blue and red line intersect at point P, a right angle is created. If you know that information, then you can conclude without doubt that AB is tangent to circle O. So it's just the converse of what I just said. So the original theorem said if a line is tangent, then it creates a 90-degree angle with the radius. Now I'm saying if a line and a radius on a circle create a 90-degree angle, then that line must be tangent to that circle. All right, so they're asking you what is the radius of circle C. So this is the hardest example that you're going to see all day. So let's go ahead and take a look at this. We want to find the radius of the shape. Now we know that AB is tangent to circle C because the right angle is created there, but they're asking me to find the value of x. Well, it's a right triangle, so I can use Pythagorean's theorem. So x squared plus 12 squared, keep in mind this is my hypotenuse because it is across from the right angle, is equal to, now what is that length? Well, it's x plus 8 squared. Yes, I told you this stuff wasn't going away, and here it is again. Let's take a look at the left-hand side of the equation first. X squared doesn't change. 144 is the value when you square 12. Let's do a little bit of algebra here. X plus 8 squared is really x plus 8 times x plus 8. If you choose the box method, x times x is x squared. 8 times x is 8x. X times 8 is 8x. 8 times 8 is 64. So you get x squared, combine your like terms, so you have x squared plus 144 is equal to x squared plus 16x plus 64. And from looking at this, you're probably thinking, you know, this is going to be terrible. Well, it really isn't. Solve for x. Well, get your x squareds all on one side. Okay, so I minus my x squareds from both sides. Cancel, cancel. So now you're left with 144 is equal to 16x plus 64. It's not bad at all. Subtract your 64 from both sides. Okay, when you do that, you get, I think, 80 is equal to 16x. And then divide both sides by 16. And I believe you get 5. Okay? So your radius for this is 5 units. Okay? Again, the next example is identical. Pause it, try it on your own, and then check your work. All right, so again, let's go ahead and take a look at this. They want to find the radius. We know that a right angle is created because they've given me that information. Okay, so I take x squared plus 10 squared is equal to my hypotenuse, which is x plus 6 squared. Well, the left-hand side's easy. X squared is x squared, 10 squared is 100. If you want to, actually, you know what? I'll box this one too. If you wanted to FOIL this, you certainly could. You'll get the exact same thing. X times x is x squared, 6x, 6x, 36. Okay, these are your only like terms. So the rest of your equation reads x squared plus 12x plus 36. So now you want to subtract or get your x squareds on one side, which requires you to subtract x squared from both sides. Those cancel. Those cancel. You have 100 is equal to 12x plus 36 minus your 36 from both sides. 64 is equal to 12x. So if you divide both sides by 12, you get x equals 5.3 repeating. So that is the length of your radius there. All right, moving right along here, we now need to know if these lines are tangent. Okay, so is ML tangent to circle N? Well, what they're really asking you is this triangle a right triangle or not? That's what they're really asking you, because if it is a right triangle, then you know that if that's a right angle, then this line is tangent. If it's not a right triangle, then this angle is not a right angle, therefore this line is not tangent. That's what they're asking. So this would have to be my hypotenuse, so 7 squared plus 24 squared has to be equal to 25 squared. Okay, well, if I do 7 squared, let's do it over here, I get 49 plus 24 squared is 576. That needs to equal 25 squared. Well, 49 plus 576 is 625. Does that equal 25 squared? The answer to that question is yes, it does. 625 is equal to 25 squared because that is also 625. Therefore, this is a true statement. Therefore, this is a right triangle. Therefore, the answer is yes. ML is tangent. Okay? Take a minute, pause the video, try the next example on your own. Keep in mind before you pause that they're using the exact same picture with new measurements. Okay, so you can erase this stuff and change your measurements for L, this would be 4, ML to be 7, and this to be 8. So pause it, try it, check your work. Okay, so if that is your information, the 4 squared plus 7 squared needs to equal 8 squared. If you get a true statement, you have a right triangle, therefore you have a tangent line. If you get a false statement, then you do not have a tangent line. So 4 squared is 16, 7 squared is 49. That needs to equal 64 because 8 squared is 64. When you add 16 plus 49, you unfortunately get 65, which does not equal 64. Therefore, it is not tangent. Okay? Because, let me just repeat this again, this did not give you when you use the Pythagorean theorem, it gave you a false answer, right? 65 does not equal 64. That's a false answer, okay? So if the Pythagorean theorem doesn't work, it's not a right triangle. Well, if this is not a right triangle, angle L is not a right angle, and if this is not a right angle, then this line is not tangent to that circle, okay? Hopefully that makes sense. I know it's a lot, but hopefully it makes sense. Your last example, or I'm sorry, last theorem followed by 2 examples. If 2 tangent segments share a common endpoint outside of a circle, then the 2 segments are congruent. So in this picture, AB and CB are both tangent to circle O. They share the endpoint B outside of the circle. Therefore, these 2 line segments have to be the exact same value. Okay? So moving on to our second to last example. In this example, they want me to find the perimeter of triangle ABC. Now, I need to express something to you. When it says that a circle is inscribed in triangle ABC, if you think back to chapter 5, when we talked about inscribed circles, that means that this circle touches AB one time, it touches AC one time, and it touches BC one time. So in other words, all of the lines that look to be tangent are tangent at the point indicated. So this circle is tangent at point D, this circle is tangent at point F, and this circle is tangent at point E. Okay? With that being said, since all of these points are tangent, well, now we can start to fill in some information. The perimeter means the length around this triangle. Well, we know that this is 10, we know this is 15, and we know that this is 8. We need to know this piece, and this piece to add them all up to find the perimeter. Well, the theorem I talked about just told me if two tangent lines share a common endpoint, then those lines are congruent. Well, AD is 10, and AF also is tangent and shares common endpoint A, so this is also 10. FC is 8. CE is also tangent to the circle, and they share a common endpoint C. Therefore, CE is 8. DB is 15, and EB is also tangent to the same circle, sharing endpoint B. Therefore, this is also 15. So, to calculate my perimeter, 10 and 10 give me 20. 15 and 15 give me 30. 8 and 8 give me 16. 20 plus 30 plus 16 give me 66 centimeters. Okay? Now, I would tell you to try the next example on your own. However, it is slightly different, so I'm going to advise that you not. You're welcome to try, but I'm going to advise that you don't because the directions change slightly. In this case, the directions are telling me that, again, the circle O is inscribed in triangle PQR. Cool, that's the same. But now it tells me the perimeter is 88 centimeters. They are asking specifically for the length of QY. Now, again, the inscribed business is the same thing, okay? So I can apply that same logic here. All these X, Z, and Y, those are all points of tangency. Therefore, PZ and PX, I'll do these in red, PZ and PX are the same length. They're both tangent to the circle and they share endpoint P. Therefore, PZ is 15. Well, ZR and YR are both tangent to the circle and they share endpoint R. Therefore, this is 17. Now, this and this piece, I don't know. So I'm just going to call them X. Well, your little equation, and let me back up. I can call them both X because I don't know their value, but I know they have to be the same length. Okay, so whatever the length is, it's the exact same. So I can call both of these X and X. Okay? Well, I know the full perimeter is 88, so I know that 15 and 15, I'm going to just make the addition a little bit simpler, is 30. 17 and 17 is 34. Plus X equals 88. Okay, well, 34 and 30 add up to give me 64 plus, now, X plus X is 2X equals 88. So now I minus my 64 from both sides. 2X is equal to 24. Divide by 2. X is 12. So each one of these lengths up here are both 12. If you have any questions, please make sure that you email me. If not, have a great night.